All right. All right. So without any further delay, let's start our session. So I know many of you already know about me. So no need to give introduction to those who already have done classes with me. But who joined the first time? I can see many people joined the first time. So let me just give the little bit introduction about myself. So myself, Pankaj, having more than 13 plus year of experience. And I'm like multi-technology kind of the expert where I'm dealing with the Cisco SD-WAN, Versa SD-WAN, security in the Palo Alto ASA checkpoint, LTM, ACI, for the data center and the routing, switching and wireless. So almost I have touched each and every technologies, and I keep working for the complex scenario like architect level. So I know where how the things working in the industry and how the things is going to be implemented in the new any project is coming to your organization and the challenges as well. So if you guys having any kind of the question, always try to ask me. I don't have any issue to give the answer. I'll try my best to give the answer. If I don't know, I'll try to search for you and I'll try to give you. Okay. So still whatever stage you get in your life, still there is a chance of the improvement and the learning. So learning is not never going to stop. The technology is keep evolving, and we all have to just upgrade ourselves. So this is the platform where I keep meeting with you all. That is a GuiNet technologies. Okay, so you guys having any kind of the query question, you can just reach out to website and contact on this number and try to send an email on this platform. So probably some person sitting behind of this platform, like support team, they will definitely try to give the answer about your queries. So today's session we'll have a discussion about the Cisco SD-WAN. That is a dedicated module. We are starting from here, but next week onward, that is the Versa SD-WAN also going to be start. But what I will suggest, anyone who is just planning to enter in the Cisco, like any SD-WAN technology, we having a lot of SD-WAN technology available in the market, like Cisco, Versa, Palo Alto, Silver Peak, Velo Cloud. So any of the SD-WAN technology, whatever you wanted to get training on those technology wanted to work, the base fundamental will remain same. Only the vendor specific thing is going to be changed. Like in Cisco and Juniper, you must know Cisco having a different command line, but Juniper having a different command line. But they all run routing protocols, right? They run the BGP, they run the OSPF, right? They run the other static route. So both vendor run the similar kind of routing protocols and the output will remain same. The routing is going to work in the similar way. Either you run the Cisco box or Juniper box or like HP box, Brocket box, or the Huawei box or Nokia box. So any of the devices, whatever you want to just, do the routing switching, the concept will remain same. Only what is going to be changed, the hardware architecture, the command line and some show command and troubleshooting command, that is going to be changed, but baseline remains same. So similar, likewise, I mentioned that in the market, we're having a lot of vendors like Cisco having the vendor, which is dealing in the, SD-WAN technologies. Also, we having a vendor. Let me just use this one. So we having a Cisco, we having the Palo Alto, very good solution. I'll start batch on the Palo Alto very soon. Versa, SD-WAN, we having the Velo Cloud, right? That is a Silver Peak. Also, we having the SD-WAN, FortiGate. We having the so a lot of vendor available in the market. So every vendor having their own SD-WAN solution, but the SDN, that is software defined network, that word where it came and what all technology behind of this software defined network technology, which I'm going to just discuss in after a few minutes. So that will remain same in regard of the what vendor you are talking. I'm not going to talk about the vendor specific like Cisco, Palo Alto, Versa, Silver Peak, like whatever we have, and the FortiGate and Velo Cloud, but your baseline, how the SD-WAN is going to work and what is the meaning of the defining the SD-WAN, how it is going to be make difference with the legacy WAN technology, which we know as the MPLS, that is quite popular, or we can say simple wide area network versus SD-WAN, right? Software defined wide area network. So that differences I am just going to explain you guys, so you just understand. So the baseline will be remain same. Whatever the technology I'm just going to discuss regarding the SDN, that is going to remain same, but only product based things is going to be changed. Like if you're working on the Velo cloud, that command line would be the change, GUI mode would be change. If you're working on the Silver Peak, that is going to be changed, command line and GUI going to be changed. So no need to worry. I would recommend, because Cisco having the largest stake in the market and many customers are using the Cisco SD-WAN solution. So I would recommend, whenever you're having the any kind of the SD-WAN understanding, just go with the Cisco, at least understand how the technology is working. And once you'll get the idea from Cisco, you can learn any of the SDN solutions. That is going to just take a little time and little effort to just memorize you the command line and GUI stuffs. But the underlying concept will remain same. So hope you guys understand about this thing. You guys can always ask the questions. If you're having any kind of the question, just feel free to ask. I don't have any doubt to give answer. Okay, no need to worry. So in this PPT, like recently we launched the Palo Alto courses, which already batch started, and that second class is going to happen on this Monday. Cisco SD-WAN we are starting today, and next week Versa SD-WAN. Similarly, one by one, all courses will be started. So I'll keep informing to you all whenever what courses is going to be started. So let's focus about the Cisco SD-WAN. Let's start our session. So guys, why SD-WAN? So this is the main question. Why SD-WAN? Why basically we need a SD-WAN solution? So this is something where I can tell, without SD-WAN, our WAN technology was running fine. Okay, there was not an issue. Absolutely, there was not an issue. And still, if we are going to use the WAN, they are going to serve your organization. So where is the problem, and why Cisco SD-WAN come in a picture, right? So this is the like key questions. I must say this is the key questions for everyone. So let me just give one story why this SD-WAN come in a picture and why it's become more relevant nowadays, and why everyone is talking about SD-WAN, why people are not going on the legacy WAN technology. That understanding is most important for you all. If you are not understanding that level of things, probably if you go for any of the interview, they will ask why SD-WAN. So probably you're not able to give real-time example, why SD-WAN, why not WAN, why not legacy WAN. So let me just focus about that. So here is two terms, that is the WAN versus SD-WAN, right? So if I talk about the WAN and if I talk about the SD-WAN, so the first difference I can see, WAN, if I just make a full name, wide area network, right? So it's a pretty straightforward wide area network. But when I use the SD-WAN, then we having like prefix where we are going to add here software defined wide area network. So we having additional things here we are adding, that is software defined. When I talk about the software, that means you must guys having some kind of the question coming in your brain. If I'm talking the software, that means something we are putting intelligence in legacy WAN, because it's a software driven things. So software defined wide area network. So that is like just the definition of the WAN and the SD-WAN in the full name. Now let's go in the deep dive. What is the WAN and why the SD-WAN? So what was the happening? Let's say suppose you are working for any of the organization, right? So what scenario you having? You must have to take the circuits. Might be you are going to take the circuit, that is your one of the router, and this circuit might be you have taken to AT&T, right? And you have taken another router, that circuit you might be taking from the any kind of the like Verizon, right? This is another ISP. And this is the cloud, might be this is the MPLS cloud, where the both circuit is connected, right? So you make this is your primary circuit, and this is your secondary circuit, right? And behind this, what is going to happen? Behind this, your LAN is going to be connected. So this is your LAN is going to be connected. And behind LAN might be your end PC, end server, end user, anything could be connected. So this is your legacy WAN technology I'm talking, right? So how this still this is working and how this was working in the past. Many of the organization keep already changed their WAN infrastructures, but still some of the organization are using the WAN, or I can say majority of the organization are using WAN, but because transforming the legacy WAN to the SD-WAN, it's taken time, might be 4 and 5 year or 10 year, then the completely across the globe, the things will be changed. But still it's a high demand in the market for the SD-WAN engineer. I'm telling you, finding the SD-WAN engineer in the market, skilled SD-WAN engineer is a very tough task nowadays. Not a very good SD-WAN engineer available in the market. Available, but they just having the very basic knowledge due to the lot of issues, like they don't have proper labs, they don't have proper kind of the implementation plan, they don't know how to create the policy and template and troubleshooting. So that's why like a lot of issues we have. And I can must say one is the most issue, the infrastructure to do the lab and testing. So that part we'll discuss how you are going to get lab and all in later stage, but just focus here about the how the WAN was working and is working right now. So let's say suppose this PC want to talk to internet. So how the traffic is going to be processed. So this PC want to go on the internet, might be it will land to the switch, that is a LAN, and via this circuit, it will land on the R1 and it will go to the internet. And this is your primary path. Might be you're running the BGP or a static, anything you are running, and based on that, it is going via the primary path. But if this path goes down, that it is going to take via the secondary path. So this is how your legacy WAN was working. That I can say 80-90% scenario we having. We taken the two routers, but at a time one router acting as a primary, one is sitting as a just idle, and it will only come in effect when primary goes down. But some scenario you also find there is some kind of the load balancing also happening. Actually not load balancing, that I use the term load sharing. Load balancing and load sharing is two different terms, and you guys must know. I'll tell something what is the differences between that. So it is a load sharing kind of the stuff, because we can't do the load balancing here unless and until load balancing required a multiple factor to just send the equally traffic between the two links or two routers. So that is it looks challenging, but still we can do in some point of time. But the correct word is a load sharing. So here, what is going to do that? We can do the load sharing based on the prefixes, based on the IP address, source IP address, destination IP address, and we can try to send half of the traffic via this link and half of the traffic via this link. So it's still, if one router goes down, full traffic will shift here and full traffic shift here. So this is the based on the prefix. But let's say suppose you want to do some deep dive, like you want to send the traffic based on the applications, right? You want to send YouTube based application traffic via this link. Probably this is something not possible in the legacy WAN. You want to send WhatsApp traffic via this link. Probably this is also challenging, because our routers legacy WAN, they doesn't understand the applications, right? Makes sense? They don't understand the applications. They understand the routes, they understand the prefix, they understand the port numbers, but they don't understand the application. So application based routing, if you think, probably we can't do in the legacy WAN technology. You can't send YouTube tab application traffic via the R1 or R2. That is quite difficult for us. But if I talk about the SD-WAN, absolutely it is possible. Okay, I'll touch this part later stage. So just one thing, like we can do the plain routing, even at a one time, one router acting as active, one is the passive. So that is another point. So at a time, we are utilizing one link effectively, and one link just sitting idle, and we are paying the full cost, and it will only come in a picture when primary goes down, then secondary comes. So unnecessary, we are wasting our cost, right? So that is additional factor for the everyone. Now moving forward, right? If I move forward, if I talk about what other factor we have, so let me just. Let's say suppose this is again scenario. And in this scenario, what is going to happen? Let's say suppose, again, we have R1 and R2, and this link having any kind of the packet loss, any kind of the packet loss. So what is going to be happen? Because this is a primary and there is a packet loss. So your kept traffic is going via this. The link is not down, very important. The link is not down, so your failover is not going to happen. But link performance went down. Like there is a jitter in that link, there is a loss in the link, there is reliability went down of the link, WAN circuit. You must guys know about reliability went down. So if even reliability went down, that means your link is not performing well. And because your link is not performing well, your traffic is going to be impacted. So if your traffic is going to be impacted, you must have some kind of the business downgrade. And if their business is going to be downgrade, you might having a trouble situation, right? So think your link having an issue, your performance is down here, but still you don't have any provision. You can fail over traffic on R1 to R2. So this is something not good, right? So what is going to happen? The things is going to happen. There would be alert is going to be created. Not alert. The customer is going to, there is two kind of ticket. One is the proactive, one is the reactive. So proactive ticket, which is where it is automatically going to be created. Reactive is something customer is going to be created ticket for you. He is going to complain, call to NOC person or SOC person. Hey, I'm facing slowness issue in my application. I'm not able to access my application correctly. So if the customer raise the concern, based on that, your L2 and L3 or L1 engineer is going to be assigned to that ticket. And they are going to check what happened. What is the source address? What is the destination address? How can I check? So user will give the source address and destination address, and you'll just try to do the trace. And when you do the trace, you come to know my traffic is going via this primary link. And then you go to the primary router and we'll try to check what is my WAN status, AT&T circuit status. So you try to do extended ping, you'll try to go and check the SO interface detail where you'll find there is some error, runs, nut, like whatever we having. So all kind of errors, CRC, you are going to check on the interface and you figure out even the reliability and load as well. So you figure out might be there is error on the circuit, their reliability went down. And based on that, you tell to your boss, your team lead, your managers, hey boss, there is an issue in the circuit and probably we have to do the failover. So now your boss or might be your team lead or some your senior person from your organization is going to give the approval. Hey, okay, now there is a service is impacted. So probably you can shift the traffic from R1 to R2. So that is going to happen manually, right? So you think your WAN is running, but still there is a problem, but your router is not capable to do that thing automatically. So what you have to do, you have to do and do the failover manually. So might be in LAN you are running the OSPF, WAN you are running the BGP. So again for that, very skilled person is going to require, might be L3 or L2, kind of the L1 people might not having that much visibility. I can see some L1 are very strong in their knowledge as well because they work very hard, but sometimes even the L2 and L3 make mistakes. Why? Because they not understand correct like routing protocols behavior, which is running a LAN and WAN. And sometimes they do some silly mistakes. And because of that, the failover correctly not happening in the production environment. So that is another challenge. But let's say suppose you just fail over the things and your start traffic going via the R2 and then everything is settled. Customer happy, say, okay, no problem. Now I'm able to access the application. And once you report that circuit issue to AT&T, they repair that and then they confirm now my circuit is fine. Then again, you have to roll back your failover. Then you make the normal. So there is a huge like effort is going to utilize. One, first, customer have to put effort to tell you there is issue in the accessing the application. So first, customer effort. Second, engineer have to do the troubleshooting and figure out where is the issue. That is second, the engineer effort. Then third, they have to do the configuration for the failover. And fourth, they have to again the rollback when circuit is going to be up and report to the ISP. There is some issue on the link. So there is a lot of effort we have to put. But let's assume the scenario will remain same. And if I am going on the SD-WAN solution, I have the R1 and R2. Again, the same scenario. and they are connected with the MPLS, and this is connected via the LAN. Let's this is connected via LAN. Again, my PC is connected here, and the same scenario is going to be happen. Again, my circuit is from AT&T, and this is a Verizon, and this router having the link performance issue or any kind of the congestion, any kind of the issue. This time, if this is the SD-WAN solution, this is not going to ask anyone, hey, I have a problem or my application has been degraded. It will check automatically. There is some problem. My link having some problem and I have to do failover. This is the brilliant router, right? I can say, because why it's a brilliant? Because they having a capability of the software defined capability we have inbuilt there that was missing in the WAN. So because we develop one of the software, and based on the software coding, we are telling to the router, hey router, now you are the super router, not a normal router. You know that how to understand your traffic pattern, how to read your circuit health status, how to read your application status. And if you read that, if you find there is some issue, then do failover. No need to ask anyone. So see, if the failover automatically is going to happen, how it's cool for the customer, how it's cool for the engineer, how it's cool for the automation. Customer never going to realize there is some slowness. So the first thing, customer, that is eliminated. Customer never going to realize there is slowness. When the threshold is going to meet of the slowness, the R1 is going to automatically shift the traffic. How cool. Second, your L2, L3 engineer, the failover and complexity they were experiencing in the past, they also not required. They no need to check what is running my LAN, how the redistribution is happen, when I disable the OSPF, is it happening or not? So they no need to do anything. Router will automatically do, right? And the third thing, most important, even the circuit restored, the auto rollback is also no need to do anyone. It will also automatically roll back to the secondary to primary. So what you have to do, that router will generate one alert. There is some circuit performance issue. So one task to contact your ISP, that work you have to do. You figure out your router reported this circuit performing not well. They having the high latency, error and loss. Based on that alert, that is available in your dashboard or monitoring system. So see, here is my Cisco SD-WAN lab. You guys can see this is my complete, one of the best SD-WAN lab I can say, because it having a lot of complexity. Okay. And in this lab, lot of kind of scenario we are going to do that. So in this lab, in this dashboard, we'll probably figure out what is happening in my network. So if you go in the where it is, so monitoring, where is monitoring? Yeah, so here you can go in the events. So you probably will see which link is performing what type, the alert, major, minor, severity, you can see that, and which link goes down, why it goes down. So all kind of things you are going to figure out from here. And based on that, even you can integrate this of your third party monitoring system like SolarWind and some other tool are also available in the market. So based on that, probably you come to know and work with ISP. Rest of the things, you no need to worry at all. So this is what beauty of the SD-WAN. And this is why everyone is just going to use the SD-WAN. So two things, two aspect I have just discussed. One is the application aware routing, auto failover. And the third thing, what I'm going to discuss, that is also very important. So let me just a little bit go on the next slide that will give some kind of overview, the legacy WAN challenges. And that all challenges is going to overcome in the my new WAN technology that is known as a SD-WAN technology. So two things already we touched. That is, my legacy WAN doesn't having the understanding about the applications aware routing that my SD-WAN have. And the second things we discuss about the bandwidth issue, any kind of the congestion we having, any kind of the CRC error, link performance issue, whatever we have, that is also going to address by the SD-WAN automatic, no need to do anything. Now I'm talking about the complex operation. So let's see, think about this way. Let's I'm just giving the very layman example. Let's say suppose you're having 100 sites. Okay. If you're having 100 sites, so you might having a two router of these sites, 2 into 100. So how much router we have? That is 200 router we have. And let's say there is a requirement, the current iOS running on the router, they're having some kind of the bug and you have to upgrade the iOS. So what you have to do basically? So once you have to upgrade the iOS, what you have to do? So basically you just have to upgrade the iOS, but before upgrading, you have to do a lot of work. The first thing, you have to check how to download the iOS. So you have to download the iOS somewhere in their TFTP server. You have to make reachability from your all router to TFTP server, right? Or if you're not having a TFTP server somewhere centrally, so every site you have to arrange the field engineer who can download this software and go with the laptop, and laptop can be made as a TFTP server, right? And then each and every router you have to take a console, and after taking the console you have to upload the software. So software need to be uploaded. So once your software will be uploaded, then probably you also have to take the config backup and all running config backup, and then you can go for the iOS upgradation process. So a lot of steps we have to do, like downloading the software, sending the FE on the site, taking the console and uploading the software, backup the configuration, and then iOS are going to be upgraded. But this is something steps. I can say this is something steps, but still there is a challenges. Even I've seen you arrange each and everything, but still what kind of challenges you are going to face. Let's say suppose you send to FE on the site, that FE is a field engineer, okay? Site field local engineer, we can say field engineer, who went to the site. After reaching on the site, what basically they do that, they are going on the site, but after going on the site, their network is not working, internet is not working, they are not able to share the screen on the WebEx, okay, or Teams or Zoom meeting. So if they are not able to share the screen, how remotely you can upgrade the iOS? So sometime I have seen upgrading the one router, entire 8 and 9 hours shift has been gone, and sometimes it's successful, sometimes it's not successful. So the mean to say, the complexity come here. You have to perform a lot of work, lot of things in real time to upgrade any minor changes on the routers. You have to go each and every individual routers to perform these activities. You cannot perform this central iOS upgradation via the one tool. If you want to do that, you can do, but you have to pay additional amount to purchase a third-party tool, which tool need to again integrate with your infrastructure, and then it is possible. I'm not negating it is not possible, but it is again going to give a high cost to you. So the complexity is going to be high, cost is going to be high, but the same thing iOS upgradation I want to do with my SD-WAN solution, it's just a one-click job. Let me show you how it is going to happen. If we're having 1,000 router, 1,000 devices, you can go and no need to field engineer, no need anyone. You just click and it is going to be upgraded. Let me show you. So let's say suppose this is a vManage. So if you don't know what is a vManage, no need to worry. So let me just little bit give the name so you guys can understand. So this is the vManage, this is the vBond, this is the vSmart, this is the root CA. Okay, so we'll discuss one by one. Just forget about root CA for time being. It's not the SD-WAN component. These three are the SD-WAN component, and these boxes are the vEdge routers. That is the actual router which is going to be deployed on the site, and these are the controllers which are sitting on the somewhere in the your central locations. So I'm logging to this location, that is control location, that is known as the vManage, and this vManage is looks like in this way, right? So by sitting on this vManage, if I want to do any kind of the steps, like I want to do the iOS upgradation, software upgradation process, you just have to go in the maintenance. And here, after going in the maintenance, let's say suppose here I just onboard 2 routers. Still I have a lot of routers, 3 and 4, 1, 2, and 5. I not onboarded it till now, but I will onboard with you all guys from the coming classes. So we'll start from 0, how it is going to happen. So you just have to select these and you just have to upgrade the image. And see what image right now I am using, that is a 19.2.3. So this is the latest image. I can say 20 and 20 series is running. That is a quite latest, but this is the below that 20, and below that image we having the 18 series. So many of that organization and you have seen that 18 dot series of the iOS has been using, but here I'm using the very latest one, very compatible with this EVNG. So that is going to give a more features. So 18 is like quite old. Some features are hidden, but I'm just using the latest one for this platform. So here you can see 19.2.3. So if you want to upgrade iOS from 19.2.3, you just have to download that iOS. Okay. And once you just download the iOS, you just have to upload that iOS. So here you have to go in the software repository. Here you can see, and you can just add the new software for whatever you want from any server. So you just have to add the new software from here. That software is start showing here. I'll tell all the process how it is going to happen. But the story is, once software will be available, you just have to go and select the devices in one go and just upgrade. And once you click on the upgrade, then available software will show here from the repository, and you just have to click and it is going to be upgrade. So how cool, how easy? By setting one central location, I have a 2 routers, might be a 2000 router, might be a 3000 router, but I can go in the one go. So how much time I'm going to save, how much cost I'm going to save? Earlier in my scenario, I was doing 2000 router, might be I need a 20 engineers, might be 30 engineers. I have to pay 30 engineers salary, and they have to work very hard into 24/7 to upgrade all iOS. But here, just one engineer going, and within some 1 hour or 30-minute time, they can upgrade all the iOS. So how cool it is. So what I'm going to save? The complexity of network I'm going to save, the cost of the things I'm going to save. So this is how SD-WAN also become a very popular. So it is very easy to do the configuration, deploy the configuration, troubleshoot the network, saving the cost, right? Guys, any question till now, anyone? Because I'm speaking since last 30 minutes. So you can guys ask me any question. You can just put your question in the chat so I can take and I can try to help you out. I can say.
Sir, I have a question.
Yeah, please go ahead.
Just when we're talking about, just maybe I'm getting a bit confused with the previous what points you were discussed about the backup route and all those things, which is like a fallback. Isn't that the same what we could achieve in the VRRP or HSRP setup?
Yes, you're right. So see, VRRP and HSRP, they are the high availability, high availability gateway protocols. So what they basically do, they basically, just hold on, where my pen creating some time problem. Just give me 1 second. So it's really good questions. So what is going to happen? So you are talking about this R1 and R2, right? And this is again WAN. This is your scenario, right? Where MPLS is going to be connected.
That's right.
And behind this, we having the LAN, right?
Yeah.
And this is how it is going to connect it, right? So let's suppose you are running the HSRP here, right? So HSRP, VRRP, whatever you are running, or GLBP. So it's a like LAN high availability gateway protocols. We can see that are a family of the FHRP. So basically, it is going to provide. Let's suppose this is one PC. We have to give a gateway address, right? We have to give one of the gateway address for this PC. So let's say suppose I'm not going to use HSRP and VRRP. So for this PC, what could be the gateway? Either this router interface IP address or this router interface IP address. Make sense? That is a physical IP address. So let's say suppose if this link goes down and you have given the gateway of this PC of this router, then this PC can't able to access the MPLS, right? Make sense? Look logical. So in this case, your network is not robust, not good. So what we use the high availability of the LAN. So that protocol is known as HSRP or VRRP or GLBP, where we are not going to use a physical address which are assigned on the router interface. We are going to use the virtual address that is known as the virtual IP that is going to nowhere exists on the physically. So what we are going to do in this PC, I'm going to tell you no need to use this interface IP address and this interface IP address. You just use the VIP virtual IP address, might be any IP address 10.10.10.1, or your PC IP is 10.10.10.10, and this is a 2 and this is the 3. So this is the VIP address. So this PC will keep sending the gateway request to this virtual IP address, and HSRP will act as a gateway redundancy protocols, where it will give one router as a primary, one as a secondary, based on the priority whatever you are going to configure. So this going to just protect your LAN. They are not going to affect your WAN. So is it the same you're trying to ask? So this is something limited to LAN.
Yeah, but there's a other thing. I mean, we also can set protocols on the rules on the other side, right, of the LAN, which is going towards a WAN. So if there's a dropout, we can fall back on the second path.
So that basically happen. The tracking is going to happen. Tracking is going to happen. So they are tracking. That only comes in a picture when you lost the reachability. You lost the reachability. They are not going to just fall back in normal scenario, right? When we lost the reachability, let's suppose your link goes down, right? Yeah. Let's suppose you having this link goes down. You lost the reachability of any of the public IP address for which you are tracking. So in that case, it is going to fail over. But let's say suppose this link utilization is going very high. Bandwidth is going let's 100% link is chalked, but still your link is not down. Your public IP is reachable. So it is not going to fail over, right?
Yes.
So the failover condition is in case your link is going down or your WAN IP for which you are tracking, that is unreachable, then only it is going to be failover. In normal scenario, it is not going to happen. So that's why it is not more intelligent, likewise the SD-WAN. So it makes sense for you? Snell?
Yes, got it. Yes. So it is basically okay. I got it. And my second question was about as you said, we can update the routers iOS. Is that only for routers, or is it possible for applications as well to be updated? So like how we use software configuration manager for updating the softwares. Like the routers are updating the iOS version. Similarly, we have the software updates in deployments. So is SD-WAN also capable of doing that?
See, this SD-WAN platform, what we are referring, they are just having a capability to just do the iOS upgradation for the routers and controllers. See, we don't have any kind of the features where we can upgrade the things based on the applications. So that is a different things that might be managed by your application team who is just managing the server and all. Okay. So this SD-WAN platform just limited to the SD-WAN related boxes.
Sure. No, all good. I just had that question. All good. Thank you.
Thanks for asking the question. Anyone else having a question, guys? Please feel free to ask.
Pankaj, I have one question.
Yes, Ramakan sir, please tell me.
Okay. Actually, as you said that we can upgrade the image on all the devices on the router. Okay. Right. So have you faced any kind of issue when you said that, let's say I have my 100 sites, okay, including my data center.
Right.
If I wanted to upgrade the image the same time, so this might be a shutdown activity, right? Or this might be during the upgrade, your router may get reboot or something like that, right?
Definitely, that is going to happen, right?
So what is the best practice?
So Ramakanji, the best practice always recommended. See, whenever basically we do for any router upgraded process, so we just have proper change things, and that is approved window for that. We can do, we having a privilege, we can do n number of devices at a one single click, but that is not recommended for any organization. Let's suppose you do 100 router and some of the router not came up after the reboot or not compatible. Then there is might be multiple P1 is going to open for you. So that is recommended, like site by site you can do. It is just going to take some time to just upload the process, might be 20-30 minutes maximum. To just boot up, download and upload the software and all. So just have the precautionary window with you that should be approved. And once it is successful, then you can move to the next site. So this is how basically we follow in industry.
Okay, now tell me one thing. Let's say I have one site, okay, identified, and if I wanted to upgrade the image, so the image has to be uploaded on your one of the repository, then you will fetch that image through the controller, and controller will then push to the that remote router. Okay.
Right.
So let's say if I have an existing OS running on that router, so does it also, what is the normal procedure? First it push the image, then upgrade, or it's a real-time upgrade?
It's a real-time upgrade. It's once you click the upgrade process, it is going to upgrade and reboot, and then your software will be upgraded. The default version.
Okay, but does it check initial verification whether that router has any free memory available or not available, something like that?
Definitely. If you don't have memory, it is full, then it will give the throughout the errors. It is not going to copy the image, not going to download and copy the image to the router. It will throw out through like simple normal router when we just try to copy the iOS, right? You must be aware about that. So when we having the less memory available, let's suppose we having the new iOS which having the 500 MB size, right? And I'm just going to upgrade the iOS. So when I try to copy the iOS from the TFTP server, it is going to stop in middle of the copy, right? Then we come to know why it is not copying. So we come to know the space has been full when we check the directory and all. Similar thing, it is going to happen here also. It will start the copying the iOS, but if you don't have the space, it is not going to allow to complete the process. So it will throw out the error.
Okay, got it.
Thank you, Ramakanji.
Thank you.
All right. So anyone else, guys, having any question? All right. So yes, Rajesh, you want to ask something?
Hello.
Yeah, your voice is a little bit low.
Yeah. Hello. Hi. I'm done with CCNA. So any prerequisite for this course?
So Rajesh, say if you have done the CCNA, so you must having the understanding about the routing protocols like OSPF, ESGRP, static routing. You know about that,
No,
right?
not. Yeah. Little bit.
Little bit. So I would recommend, like, if you're having a little bit knowledge, so at least you should have a practice on that, because for the SD-WAN, we are going to completely use the new routing protocol and some new concept, but legacy protocols routing would be also required. Like how the static routing connectivity is going to happen, how the forward and reverse route going to be, apply from the forward and reverse direction, how to make basic reachability. So that is going to be done in our labs, because you can see we are having the very complex lab where we have to make the reachability from the controller to the end sites. For that, we have to run the underlay connectivity. That is the legacy routings, like based on the static, we have to run the BGP. So once it is going to be built, the entire fabric is going to build on the very new routing protocol. So that is going to be new for the everyone. So if you don't know, everyone have to learn. That is the OMP routing protocols. But I would say basic IP connectivity you should know. So I would just recommend just go through and brush up your skill and try to do lab and all. Okay.
Yeah. Okay.
All right. So let's move it. So I was talking about like complex operations, high cost. Now we having the scalability problem, right? So every network have to very scalable. So when I talk about the scalable, I should know what is happening in my network, right? How can I modify my networks based on my intent, right? How my network is behaving with the applications, and if I know that artifacts based on the my some kind of the data, then probably I can take a decision. So if you see here in my network, so in my network, basically what is going to happen, I have a lot of devices, a lot of links are connected, and every links are doing some kind of the connectivity over the OMP, over the legacy routing, and their all statistics is going to be captured by the vManage. And vManage keep giving the one of the dashboard based output where we can see how kind of the what kind of the my link and controller are performing the activity. So the health report, vManage health, inventory, transport interface details, how my like every transport is performing, what is a loss, latency and jitter. So based on that information, which is a very granular kind of the output, what I'm getting on the dashboard, we can manipulate the things based on our intent, or I can scale my network where I need to work more and how can I improve my network. So that is also possible, which was not possible in the legacy WAN. Even it was possible, but again, you have to invest a lot of third-party tools. Then it is possible. Now moving next, that is the cloud application. So nowadays, what is happening? Applications are moving on the cloud, and this is a very important thing, guys. That SD-WAN is playing very vital role here. So what is happening? Cloud is having one of the key things nowadays in the market, and nobody is going on the data center environment where they are just going to build a physical data center, host multiple devices, invest a lot of money, and give the connection for their organization. So that is quite costly. So when cloud come in a picture, what do you have to take? You just have to take, let's say suppose AWS, Azure, Alibaba, right? We having a lot of cloud, GCP, we having a lot of cloud available in the market, right? So if we are going to connect our sites, let's say suppose I have a multiple branch sites. So this is my BR1, this is my BR2, this is my BR3, this is my BR4, and might be how can I, these are in India, right? These are in, I can say, UK, right? And again, I have the branch, that is the branch 5. I can say these are the branch 5, which in the US, right? So how these branch are going to be connected? So let's say suppose you have to take MPLS connection, and all branch needs to connect with the MPLS, right? And might be another, you having a branch 6, that is a Hong Kong, right? So all branch are connected with the MPLS, and further, let's say suppose you having a data centers, right? Some data center are hosted in, let's say suppose in Singapore, right? So this is your data center. So that data center also need to be connected to the MPLS, right? So if branch to branch communication I want to do, they can take a normal ISP MPLS link and they can do the communication. But if the application is hosted in the data center and branch 1 want to talk with those applications, they have to go via the private lease line to the data centers. Every site have to follow the same thing. So that means if your branch is located somewhere across the globe in different country, and your data center is located somewhere in the different country, so you have to take a private lease line across your all branch or data centers, and that should be very private. Even you can go for the internet as well. So you have to pay a lot of cost to taking these private connections, because every country having a different ISP, and you have to tie up with all ISP. Basically, you not have to tie up ISP, they tie up to each other to just get a MPLS circuit, the private links for you. But the end result, the links cost are very high. So if the cost is very high, then you have to pay a lot of money to just make the reachability from all branch to your data centers. And even building the data center is the an additional step that is going to add additional cost for you. So if I talk about the cloud-based solution, so again, my different branch is going to be located in different locations, but I no need to worry about the private lease line. I can simply take the internet connections, okay, and I can connect my all branches, and I can take the data center services. If I like the AWS, I can use the AWS. If I want to use the Azure, I can use the Azure. If I want to use the GCP, I can use the GCP, and these can also be connected over the internet or MPLS, whatever you want. So what is going to happen? So you're having a lot of flavors, lot of locations you will find where you can host the services based on even your geographical need. You don't need to worry about, I have to host my data center in the Singapore, Frankfurt, US, UK. You can take the local, your country base data center nearby, AWS data center where you can host the solutions, and you can bring that over your private lease line or internet, whatever you think, and you can make the connectivity. So these cloud things are growing day by day, and this SD-WAN is going to meet your all requirement based on the cloud readiness, and that legacy WAN was basically not capable to do that. Why it was not capable? Because when you have to go on the cloud, you have to maintain a lot of security parameters. And to maintain or make the connectivity with the lower cost and maintain the security parameter at the same time, that was quite challenging. You have to connect a lot of firewalls, a lot of third-party devices, and you have to take lease line connection and all. You have to host data center and all, or make the cloud connectivity and all end to end. That is quite challenging. But if you use the SD-WAN solution, that is going to help you, because the security features, IPSEC private connection is going to be formed directly from your router to the data centers, which is nobody is going to hack, track what is going on in the side of the IPSEC connection. So this is how this cloud readiness in the coming generation, it is going to make one of the important role here, where we can connect our SD-WAN feature with the cloud solution. Next is like we having the security fragmentation, like fragmented security. That means, let's say suppose using the legacy WAN technology, that legacy WAN doesn't having security firewall feature inbuilt in the routers. So what you have to do, you have to deploy the ASA security firewalls, you have to deploy the what I can say, checkpoint firewall, suppose firewall, Palo Alto firewall, then probably you can achieve your security steps. But if you're going to deploy the SD-WAN solution, they itself having the inbuilt security. You can see all security, whatever you want to do, that you can just do the URL filtering, file blocking, application blocking, that is already possible. Let me just show you in this security module. So just you have to enable it, and you can see everything you can just apply from the security point of view. That is also possible. That was not possible in the legacy routers. Now that we talk about the limited application aware, they're not having the capability to application understanding, they're having the bandwidth issues, they're having a disjoint solution, they're not having the very uniform solutions, like various standard solution. But in SD-WAN, you can deploy various standard solution across the globes, and they are going to centrally managed, and centrally they are going to deploy. So this is how the challenges was evolved in the legacy WAN, and this challenges were overcome by the SD-WAN. This is the why we are using the SD-WAN. So hope you guys at least understand why SD-WAN and what is the importance of the SD-WAN. Still, if you're having any question, please ask me. Any question, guys, till now? Because I believe this should be very clear to everyone. All right, so I'm just taking a no. If you're having any question, guys, just put me in chat, so at least I can see if you're having questions, right? So what next? So here we're having a lab, okay? And in this lab, what we are using. So let me just little bit give the overview of the lab. So once we start the session, everyone get the rack access of the lab. Okay, you guys see here. So this is the GuiNet rack, where everyone get the credential of the lab. And this is the lab, what is available here. You will get the same lab. And even you want to just create your own lab, so I can give the permissions, because now I have like a full privilege where I can give the right access to anyone. So on this lab, what is going to be happen? We having the controllers, where these controllers, we are going to do the very deep details. What is the vManage? What is the vBond? What is the vSmart? And what is the meaning of the controllers, right? And once we understand the controller understanding, we make them connectivity with the all branch sites via the dual transport. That is, one is the MPLS, one is the internet. So you can see, so every router is going to be connected with the MPLS and the internet. So once these sites will be connected, we'll step by step is going to onboard on the sites on our SD-WAN fabric, that is a dashboard, and we'll see how many sites is going to be onboarded on the my dashboard. So right now I have already onboarded 2 of the vEdge routers, and vSmart and vBond and vManage, because I just wanted to demonstrate you all how it looks like in the dashboard and all, and it is just on the very latest iOS. So this is the controller where I explain in the next session what is a vManage, what is a vBond, and what is a vSmart, and how the lab is going to build. This is a very scratch, how the connectivity is going to happen, how we'll take the GUI, how we'll make the connectivity from vManage to the vEdge router, how the root CA is going to play a role. So that we are going to understand, and the credential will be shared with everyone, right? Like who is going to register for this session. So this is about the lab little bit. After this lab, we'll go with the course content as per the Cisco official course content. So whatever we have in the Cisco official course content, we cover all the points from there, right? So whatever we can do the practical things, like where people are struggling. So people are struggling, they understand the concept, they do the basic things, but they struggle in terms of the creating the policies, right? They struggle to create the templates, and they struggle to do the failovers, like it's again part of the policies. So we'll focus more on those pain area where people are struggling, because when you go on the interview, you can justify, you know, the SD-WAN, you can justify what is the OMP, what is the vManage, what is the vBond, how SD-WAN works. But when people start going in the deep dive, right, how basically policy is going to be created, how different policy set is going to be applied on the vManage, and how it is going to push to the vEdge router, and how the behavior is going to happen, how the templates is going to be. Template means the GUI based configuration. Okay, CLI, like we having the router, you can see that vManage, and this is the one of the vManage. So I can have the CLI access also, you can see. So running configuration, I can see from here how this device is connected, what is the configuration I have done. And this is the GUI access of, this is the vManage router, right? Similarly, this is my vEdge router. For vEdge, we can access directly from the GUI of this vManage, or I can directly access via the CLI also. So here you can see I'm accessing from the CLI. So let me just change the color. So this is the router configuration. So this router basically doesn't having any configuration. You can see this is the dummy router. I just make the basic reachability configuration, so I can at least onboard on the SD-WAN fabric to just demonstrate you all. But if I click on this router, probably we found nothing is configured on this router, because even I never onboarded this router on the SD-WAN platform. So see, it is asking to first time change your password. Okay, so this new image always asks to change the password. Okay, so you can see here, this one not having any kind of the configuration. So this is about the router in the switch access. Now moving next. So the next stage, once we start understanding what is SD-WAN and how SD-WAN concept was evolved. So we'll take another 30 minutes where I explain the next thing for you guys to at least you understand how things is going to be work in the real environment in compare with the legacy WAN technology, right? So let's say suppose this is your router, right? This is your router. So in router, what component we have? What all component we have? So we can say this is a Cisco router, which model is 7604. That is a high-end router. And we having the different modules, right? One is the IO modules, one is the control plane modules, and one is the switch fabric modules, right? So once we try to compare this legacy Cisco router with the SD-WAN, how it is going to relate that. So this is one box, right? And this box is the closed box. That box is the closed box, not open box. And in this closed box, what is happening? Everything regarding the routing, regarding the like sending the packet in, sending the packet out, and doing the processing, that is central processing unit, that is a CPU for this box, that is also inbuilt inside of this box. So how SD-WAN is related to this box? So let's understand this. Basically, SD-WAN concept was driven from this box only. Without this box, SD-WAN concept never can be driven. So what was happen? So this box is a closed box. And in this closed box, we're having a three main component. That is the IO module, control plane, that is known as the CPU, and this is the switch fabric, that is the back plane, which is integrating to two modules, that is the IO module and the control plane module. So let's say suppose I'm just giving one of the example. Let's assume that you connect one of the PC on this port, right? So this PC is connected on this port. So once this PC is connected on this port via the switch, or you can directly connect, let's assume directly connected, and you having another PC connected on this port, might be directly or the switch, or might be you take the server. So this is a server, and this PC want to talk to this server. So this PC having the IP address 192.168.10.10, and this want to talk with the server. This one having the IP address, this could be the 123.10.10.10. So once PC start talking to this server, they will build one packet where it will add their source IP address, and they are going to add their destination IP address. In the source IP address, it is going to put 192.168.10.10 and destination IP address 123.10.10.10. So this is your L3 packet, that is IPv4 packet, which is known as the L3 packet. So this packet is going to be originate from this PC and going to punt to the IO module, right? It is going to punt to the IO module, which is going to receive the packet from the external wire, that is your physical wire, that is sending by the PC. So once this packet will be received by this IO module, that is the physical interface, it could be your Ethernet or gigabit 0x0, right? And this could be your gig 0x5. This is another interface. So your packet is going to be in, that is going to be punted to this interface. Once the packet will receive, what router is going to do with this packet? Is it going to do some kind of magic or some kind of checks? Yes, definitely it is going to do some kind of check, not magics. Okay. There is no magic in the technology. Everything is like driven by the some set of process. So once the packet is landed on this router is going to contact with their CPU. How to process my packet? Because CPU is just brain of the router, right? So this is just brain of the router. So this is the brain of the router. So they are going to just consult with the CPU. Hey, how can I process this packet? I just received one packet which having this source and this destination. But before it is going to CPU, they have to cross this layer. That is the switch fabric. Because your packet landed on this box. You can see this is the separate module. And this is the separate module. You can see the blue line. These are the completely separate. They are not connected here. You can see. So how it can be go here? It is not possible, right? So this is something, one of the mediator that is known as the switch fabric. Switch fabric is one of the mediator, which is going to tell, hey, if you want to contact with the control plane, just come to me and I'll help you to how to contact those control plane. And the same thing, control plane want to communicate with IO module, you have to come again to switch fabric and I will tell how to go on the IO module. So basically these backplanes boxes are connected behind of this switch fabric. You can see these are going here and they are the ASICs. They are the like circuits and ASICs are behind this. So once you insert this card, they are going to jack in and just going to touch the ASICs, which is a switch fabric. So this card is going to touch here and this card is also going to touch here. So I hope you guys are visualize what I'm trying to say. So once this is going to touch here and this is going to touch here, based on the touching, now they are integrated via each other with the switch fabric. So once now the packet is punted on this interface, it is going to tell you have to go to CPU, that is the brain of the router, and the brain is going to tell, okay, you want to go on this particular destination 123.10.10 in your packet it's having. So let me check the base routing. So it is going to contact with the routing information base, or it is the forwarding information base. So RIB is the collection of the all route and FIB is the just base route collection, where it is going to use to do the real time, routing conversion. So RIB and FIB, there are two things already available in the router memory. So they are going to consult with the RIB and FIB, and based on the RIB and FIB consultation, they will figure out what is the exit interface of this destination packet, or I can say the next hop address. So once they will find the next hop address, it is going to send out the packet from this way. So CPU will give the instruction, hey, okay, you want to go, just go via this, and the packet will go out and it will reach to destination. So this is how your closed box is going to work. So in this, we having a 3 module. One is the IO, one is the control plane, one is the switch fabric. And based on these 3 modules, it is going to be processed. So it is something available in the router. So how it is related to the SD-WAN? So let me go on the next slide. So let me just do one thing. Let me just take one of the snip of this box. So we'll take the reference and we'll keep understanding. So let's say suppose this is the snip I have taken. Now let me just clear this. Let me just clear this also. Okay. So what next? So now what I'm going to do, this is the closed box. I'm going to open the same box. This is the closed box, which having the 3 modules. I'm going to open the same box and I'm just going to put all 3 modules in the open box. And when I do this, this will become the SD-WAN architecture. And this is the SD-WAN architecture. You can see that. And again, I have the control plane modules. I have the switch fabric and I have the IO modules. You can see that all 3 components are still there, but instead of single one box, now they are the open box. So why I called open box? Because they are going to like distribute in different locations. It's not going to compact in the one box locations. So here, what is going to be happen? So your control plane module, that is known as the brain, okay, or CPU. They basically sitting in somewhere of your organization, like best place or cloud place, which is known as the controller, right? Which is known as the controller. So what is the controllers? They are the vManage, vSmart, and vBond. So we'll talk step by step later about each functionality of the controllers. So this is the vManage, where we are going to deploy the configuration. We are going to configure the configuration, but it's also part of the controller. And we call the network management system. Here you can see that vManage. But this controller can be in any country. Let's suppose it is hosted in the US and it having a 3 component, that is a vManage, vBond, and vSmart, right? So this is the brain of your router, but they are sitting in the US. Let's say suppose the IO module, what I was referring here, these are the IO modules. So in this case, your IO module are your actual site location. Might be these sites are in India, right? One site in the New Delhi, one is the Hyderabad, Chennai, and Mumbai, whatever you can think, or Bangalore. So different location, whatever we having the site location, and every site location we having the vEdge routers. So again, the vEdge router, we having a multiple ports, like gig port, Ethernet ports, whatever we having. And on this port, we have to take packet in and we have to take packet out. Scenario will be the same. So let's say suppose we're having another packet that is a 192.168.10.10. Again, it want to talk the packet 123.10.10.10 that is hosted in the vEdge. So how the things is going to happen? So in previous case, we come to know whenever this packet want to talk, they basically consulted with their brain, that is a CPU, via the switch fabric. But in this case, how basically it is going to happen? Brain is US and we have to talk locally within the router, which is in India. Then how it is going to happen? So basically, in this case, what is going to happen? The switch fabric, which is going to act and which is going to replace by, which is your MPLS, internet, or broadband circuits. So whatever the circuit ISP you have taken, they are acting as a switch fabric and they are acting as a mediator of the controller and your IO modules. So based on this controller information and IO module information, they are just going to communicate to each other. And after communicating to each other, they are just going to do the routing exchange. So this PC, once they want to talk with this server, they will go first controller via your ISP link. And once controller tell, hey, okay, you want to talk with this destination, you just have to take my instruction and send this packet via this link out. So again, your concept will remain same, but only what you have to do, you just remove the intelligence from the routers. Whatever the router we have, the vEdge router, cEdge router, whatever you have, you are make them dummy. That router is not intelligent. You just remove the intelligence and put in the controllers. So because why you are doing? Because you want to control everything centrally somewhere of your network. So this is how your open box is going to be come in a picture. So you are going to replace the controllers from your routers and you are going to put here in the central locations, and they are going to give that instruction to all. And why this switch fabric is so reliable? Why it was not earlier so reliable? Because earlier we having the internet circuits that is having a lot of problem. They are not too much reliable, but nowadays the internet circuits are awesome. They are loss free circuits. If you're taking the 100 Mbps speed of circuits, they are going to give you 100 Mbps circuits, like what I can say, the speed of the circuit. So definitely they are going to help you a lot in terms of the real time network, connectivity from their local side to the controller, and it will never going to give like some kind of the funny output where you are not able to communicate, because it's a very reliable loss free circuits are available. That's why you can quickly send the information to the controller, and you can get the information from controller, and you can just do the communication based on the controller information. And how basically this look like? So once you form the any sites and you just want to go with this, let us suppose you want to form the sites, this site want to talk with this. So how the routing they are going to form? So they having the routing, that the separate routing table. So OMP route, if you see that, I'll tell what is OMP route or show OMP session. Sorry, so OMP peer. So you can see these are the vSmart, which is going to give the routing informations, and based on the routing informations, whatever route I am receiving, I can just run the command. So IP route, and you can see these are the all routes I'm receiving here on the VPN 0 and VPN 10. So I'll discuss what is the control channels, what is the control plane. We having a DTLS and TLS control connections. So I'll discuss what are the control connections, how this control connection DTLS, TLS is going to be formed, and how this control connection is going to build over the site to the vSmart, vBond, and vManage, and how the OMP is going to be formed. What is the VPN 0? What is the different VPN, service VPN, management VPN, and the what I can say, transport VPN, that is VPN 0. And what is the CLI mode, GUI mode? So a lot of syllabus we are going to discuss in our upcoming syllabus. So probably we can go step by step. So our next class is going to be happen by the next Saturday. Okay, so that after that it will be continue. So who have done the registration, they will by today only they will get all the lab credential access. So you guys can just go through what I just created the lab, just try to log in and see how it is working. And if you face any kind of challenges, just touch with the team. They will definitely help out, or just send me the message me as well. I'll try to help out. So that's all for today, guys, from my side, and probably we can do the more like in detail learning in the upcoming classes. So you guys can ask the question now. I'm done with for today's sessions, because if I go in the deep dive, that I believe many of guys having the like complexity to understanding, right? So anyone having any question, guys? Anyone want to ask anything?
Hello.
Yeah, Rajesh. Yeah, please.
Yeah, so are you taking CCNA and CCNP also?
Yeah, we having a CCNA batch going to be start very soon. That is also possible.
Okay.
Yeah.
I'll ping you. Yeah, I'll ping you.
Yeah. So you let me just ping you.
See, I have done CCNA 3 years back. Okay, so
you done. So where you are working right now?
Right now, working in the one company.
Okay.
But there is not any like the Cisco and all. So
So what platform basically you were working? Not Cisco, so some other vendor
So
platform you were-
working as a system administrator, looking at the whole infra and the servers and all, but not whole like much in.
Okay, Rajesh. Okay, no worry, no worry. So what we can do, you can just share your contact information, okay, and we'll like let you know and we'll guide you how and when the session is going to be start. So at least you will be aware.
Yeah. Okay.
Yeah. So I just ping on the team chat. Sorry, Zoom stash. You can just share your details, so I can just share with the team. Okay.
I have your number.
Okay. Okay. Great. Thanks. All right, guys. So anyone else having any question? Or all good? If all good, then we can close this session for today. Okay, guys. Okay. So bye bye. Take care. Happy weekend to all. See you on the next Saturday. All right, guys. Bye bye.